Hi, welcome to VLSI Simplified YouTube channel. As a part of Verilog 30 days Verilog lecture series, we are in day 12. So in day 12, I'm going to explain you the remaining two shift registers, that is uh, PIPO and PISO. Okay, PIPO and PISO. First, I will tell you the PIPO and parallel in parallel out and parallel in serial out. So first, I will explain you in EDA how to execute in EDA playground, and next Xilinx Vivado, okay, and next QuestaSim and model sim, okay. So if you see the code related to PIPO, so I wrote RTL code as well as TB. So here, if you see, this is the RTL code, a simple code. So here, 4 bits of data you are loading and 4 bits of data you are taking out, okay. So module PIPO, okay, module name is PIPO, input wire 3 down to 0 D in, data in, input wire clock, input wire reg 3 down to 0 D out, okay. So D in is 4 bit of data and D out is also 4 bit of data, okay. Always at the rate passage of clock begin, D out is non-blocking with D in, end and end module, okay. So whatever the D in is there, that is coming to the D out. Okay. So this is the basic RTL code for PIPO, parallel in parallel out. And coming to the test bench, so if you see the test bench, module PIPO TB, so I'm declaring the variables for the test bench. Okay. So clock and 3 down to 0 D in with the reg data type and D out 3 down to 0 with white data type. Okay. And I need to instantiate my design in the test page. How to instantiate? Design name followed by the instance name. PIPO, DUT, okay, and dot clock, dot D in, dot D out. So whatever the variables outside the bracket are design inputs and outputs, and whatever the variables inside the bracket are test bench variables. Okay, and next you need to generate the clock. So always hash 5 clock equal to not of clock. So that means here, so it will be for the half cycle, 5 time minutes, it will be off 5 nanoseconds, and 5 nanoseconds it will be on. So that you are getting the time period as 10 nanoseconds and the frequency is 100 megahertz. Okay, initial begin. I'm making clock equal to 0. So dollar monitor is a system task. So if there any change in this variables, okay. So I'm specifying the format specifier the percentage t for time and d in equal to percentage b binary, d out equal to percentage b type binary, comma dollar time d in d out. Okay, if there any change in this variable, then it will display. And next, I need to give the stimulus. I need to give the test vectors to the design. Okay. So D in equal to I'm giving some values. 4 tick binary 0 0 0 0. After 10 time minutes I'm giving 0 double 1 0. Again after 10 time minutes I'm giving 0 0 1 1. Like that I'm giving the four variable inputs, four inputs to the D in. Okay. After 50 time minutes I want to stop the simulation, terminate the simulation, dollar finish and end module. Okay. So this I will execute in EDA playground. So for this, I need to open the EDA playground. Just I'm opening the EDA playground. So you need to log in with your mail ID. Okay. First, you need to log in with your mail ID. And whatever the RTL code is there, select all, copy, and paste. Here, right side, we need to write the design and select all, copy, and here we need to paste the test bench. Okay. So go to tools and simulators, select the tool Aldec Rivera and so run. So you can see the in the TCL console. So you given 000. So you got 000, 01110. So here you got this value. 4 bits of data you are loading and 4 bits of data you are taking out for every 10 time units. Okay, 10 nanoseconds. Okay, so like this we can see in the log file. And coming to this one, AMD Vivado ML edition, the Vivado. Already created one project in the last class now in day 11. That is shift register that opening. I'm opening that project. Okay. So file project. Open the project. Open the project. Mm, Yeah. Okay. Training and development. VLSI material. 30 days of VLSI. And or I can create one more project that is shift register. Okay. So file project. New project. Next. Okay. So what is my project name? We are in. So this is day 12. I'm creating shift register 2. Okay. This is my project name. Okay. So we are shift register 2. Project name is shift register 2. And I need to select the path. So you are in training and development. No. Okay. Yeah. Training and development. And next VLSI design material. 30 days. We are in day 12. Okay. I need to select this path. Okay. Next, and create the file name. Give the module name only. Okay. So what is my module name? PIPO. Parallel in parallel. PIPO to the location. This shift register 2. This is my location. Okay. Next, next, and next. Finish. Yeah. My PIPO is created. Go to this file. Select, copy, and paste over here. Save, and go to simulation. Add or create design simulation. Create. Now you need to do the test bench. Okay. This is my module name for the test bench. Copy this and paste over here. Choose the location. Shift register to. Okay. Finish. Okay. Yes. Next, go to PIPO TB. Select all. Copy and paste over here. Save. Now my design is instantiated in the test bench. Okay. So design name is PIPO and instance name is DUT. Okay. So if you want to see the elaborated design, go to an RTL analysis, open the elaborated design. How the tool is converting your code in terms of RTL netlist. Okay, we can see in the elaborated design. So like this, the tool is converted our code into gate level netlist. So total we design the shift register by using D flip flop. No, so inside total you have four D flip flops are there. So that I'm designing with four D flip flops and clock, and input is 3 down to 0, 4 bit, and output is also 3 down to 0. Okay, so this is the circuit of PIPO, parallel and parallel. For the simulation, go to simulation, run behavioral simulation. Yeah. So you can see the in the TCL console also. So every 10 minutes, so whatever the data you are giving, that is coming to the D out. Here 0 0 0. So D out equal to 0 0 0 double 1 0 0 0 1 1. Okay, double 1 0. Again 1 0 1 0. Okay, again 0 1 0 1. Okay, and you can see in the simulation part also. Just fit to page. So by default, you are getting in terms of hexadecimal values. So six. Six. So six means this, during this passage of clock, loading of data is happening. During this negate of clock, what is happening? That value is coming to the D out. Okay, every time. Okay, parallel in parallel out. Okay. So right click. If you want to see in the binary, just click on binary. Right click radix binary. Okay, so you can see here. So initially, like DIN is loaded with what 0 0 0 0. Okay, so DIN is loaded with 0 0 0 0. That is coming to D out during negate of clock. Again here also DIN equal to D 0 double 1 0. Okay, during the passage of clock 0 double 1 0. So that is coming to the D out during the negate of clock. Okay, like this. During the passage of clock 0011, during the negate of clock, you are getting 0011. Okay, during the passage of clock 1100, and it is coming during negate of clock. Like that, it is coming. Okay, you can see in the simulation part. Okay, and next coming to the quarters prime. So I created three folders. One is RTL. Whatever the RTL code is there, I'm writing in the RTL, and SIM. I need to give the project path in the SIM, and TB. TB means test bench files. Okay. Whatever the test bench files, I'm writing in the TB. Okay. So go to Quartus Prime. Next, I need to create the path of this project. Okay. So what is this path? Training and development, and VLSI design material 30 days. Again, we are in day 12, no? Day 12, and sim. Okay, give this folder, and I want to give the RTL file. Okay, so this is PIPO. Okay, so same thing, whatever I explain the code. Okay, so this is PIPO. One second, I'll open this RTL code. So here, this is my PIPO. Copy this and go to this water sprite. Paste this. Next, empty project. Next, so add the RTL file. Add the RTL file. PIPO, open, and so RTL file is uploaded here. Okay, and next, select any FPGA family. Next, next, and finish. Yeah, my RTL file is added. So go to analysis and synthesis. Start. Yeah, 0 errors I got. And next go to analysis and synthesis, netlist viewer, RTL viewer. Right click open. So like this I got the RTL synthesis. Okay, RTL viewer. Same as Vivado. So we got this RTL viewer. 4D flip-flops are there, clock, and D in is 3 down to 0, and D out is also 3 down to 0. Okay. And coming to the model sim, so file, new, project. I want to close this project. Project name is, let us give PIPO only. Okay. PIPO, browse. So we are in day 12, no? Day 12, sim. Okay. And okay. Add the existing files, add the RTL file as well as TB file. So RTL, you are wrote the PIPO, okay, add the TB file, PIPO testbench, okay, close, and right click, compile selected, yeah, you got tick mark. So two compiles, zero with failed, zero, no errors, okay. Go to library, work function, test bench you need to simulate, okay. PIPO test bench you need to simulate. So next you need to go to the PIPO test bench, add wave, DUT, add wave. Here you added the waves. Okay. You need to group the test bench signals as well as DUT signals. Right click, right click group as TB, and right click group as DUT. Okay. And run all. Okay. So I can see in the transcript window also. So see here. So whatever the outputs, initially X only, input is 000, output is 000. Input is 0110, output is 0110. Input is 0011, output is 0011. Input is like this you are getting. Okay. So like this you are getting this values. Okay. 4 bits of data you are loading as well as parallelly you are taking out 4 bits of data. And coming to this uh, waveform, go to waveform, expand this. So this expand this and zoom full. Now you can see. So this is PIPO D in and PIPO D out. Okay. So during this passage of clock, loading of data will be happen in the D in, and during this negate of clock, loading is happening at D out. Okay. Here also. So 10101 is loaded during this passage of clock. During this side, so you are getting 0 1 0 1 1 0. Okay. Here loading of data 0011. Here what is happening? 0011. Okay. Loading 1100, and it is coming to D out 1100. Okay. So like this we can see the waveform in the models. Okay. So this is about the PIPO. Sorry. Next we will go with the uh, PISO, parallel in serial out. Okay. So parallel in serial out, if you see the RTL code, so module PISO shift register, input wire clock, input reset. I'm using a reset. Okay. And input wire 3 down to 0 parallel in. So this parallel in is actually parallel data. 4 bits of data we need to load. No. So that's why this is parallel in. Input wire load. Okay. and there is a signal called load. Okay, when load equal to 1, it will load 4 bits of data. When load equal to 0, it will shift the 4 bits of data. Okay, one bit it will shift. Okay, so I'm declaring one shift register, that is shifter. Okay, shifter 3 down to 0 shift register. Always at the rate passage of clock or passage of reset. This is asynchronous active high reset. Begin. Okay. So passage of reset. This passage of reset I'm declaring in the sensitivity list. Okay. If reset equal to 1. Okay. I'm declaring the shift register with what? Zeros only. Okay. Else if load equal to 1, then we need to do the parallel load. That is shift register is non-blocking with parallelism. Okay. Else begin. This is shift operation. Okay. Shift operation is happens. This is the right shift. Shift right. Shift right means we are loading the data from the left. Okay. So every time when it is shifting, this will be copied. Okay. Comma one tick binary 0. Okay. This is by using concatenation operation. I am using this shift operation. Okay. So every time you are shifting the data, shift register 2 down to 0 will be copied, comma, one tick binary 0. Okay. And at last, the data will be available at the shift register of 3. So the shift register of 3 is assigned to serial out by using continuous assignment statement end. Okay. So like this, we can write the code for the PISO. Okay. Parallel loading of data, 4 bits of data, and shifting one by one. Okay. So that is PISO. And coming to the test bench, yeah, PISO. This is my test bench file. So if you see the test bench file, module PISO shift register underscore TB. So I need to declare the variables reg clock, reset, load, reg 3 down to 0 parallel in, wire serial out. So I need to instantiate my design in the test bench. Okay, design name and this design name should match. PISO underscore shift register and instance name is DUT and this is connection by name. So whatever the variables dot clock like this we need to write. So the variables outside the bracket are design inputs and outputs. The variables inside the bracket are test bench variables. Next I need to generate the clock. Always hash by clock equal to not of clock. Initial begin. Suppose clock equal to 0 and reset equal to 1. First I'm applying the reset. Okay, as this is the asynchronous active high reset. No. So load becomes 0, parallel in equal to 4 tick binary 0, 0, 0, 0. Okay. After 10 time minutes, what happens? I am desetting the reset. Okay. And after desetting the reset, I am means I need to do the parallel load. So I need to give the stimulus. Okay. I need to give the test vectors to the design. Parallel in equal to what? 4 tick binary 1011 and load equal to 1. After 10 time minutes, I'm making load equal to 0. Load equal to 0 means parallel load. Parallel shift operation. Load equal to 1 means parallel load and load equal to 0 means shift operation. So we need to do shift out serially. Okay. So how many time I need to observe? $50 time units I need to observe. After that, in order to terminate the simulation, I am using $finish a system task. Okay, it will terminate the simulation and initial begin. If I want to execute in TCL console or log file, or if you want to see in the transcript window in the model sim, I need to use dollar monitor. Dollar monitor for the time percentage T, parallel in is percentage B, load is equal to percentage B, serial out is percentage B, shift register equal to percentage B. So these are the format specifiers, binary. Okay. Time is actually time. It will execute in time and time dollar time. These are if there any change in this inputs and output in these variables, then it will display. Okay. End module. Okay. So like this, I wrote the code. This code I'm going to execute in first EDA playground. Now you see, so PISO, no? PISO, EDA playground. So this is my PISO. Uh, so just right click, select all, copy, go to EDA playground. So select the new playground, leave. So here I need to store the design file and next test bench, right click, select, copy, and here we need to paste the design and test bench. Okay, go to tools and simulator, all like Rivera. Okay, and save and run. Yeah, I got error, one error. Okay, 1 second. I'll open this code. 1 second. RTL. This is one more type of coding, like we can give like this also. Okay, so shift register 0 is parallel in, and if shift register 1 is shift register of 0, and shift register of 2 is shift register of 1, shift register of 3, shift register of 2. Like this also we can give. Okay, so just this code I am using. By using concatenation operation also we can do, or we can do like this also. So just I'm going to the EDA playground. 1 second. This is I'm going to EDA playground. Paste this and here this is the test bench. Copy this code. Test bench is same one. Right click, copy, and here you paste. Save, run. Yeah, serial out data is coming, no? Serial out data is coming. So what is the data we gave? So here in this I gave uh, actually this shift register is how many bit? Shift register is 4 bit, no? Okay, 4 bit. So first parallel in data, shift register 1 and shift register 2. Okay. So here we need to give shift register. Shift register is parallel in data. Save this. So now we'll run. First parallel load will happen. Mm, Shift register. Actually, that the data is coming to the shift register out only. Okay, loading is happening, but that parallel out data. So what data we are giving? So 1010 here 1010 is there, no? So 01010 that is coming to the serial out. Okay. So this I can see in the Vivado also. So go to Vivado. Uh, so, so discard this. This also you discard. Go to design sources. Add the create or design sources. Next, create the file name. Okay. What is my file name here? PISO shift register. Copy this and paste. Choose the location. Shift register to select. OK and finish. OK. Yes. So my design source is created. Here you need to paste your code. This is my test bench. This code you need to copy. Copy this code and here you paste, save, and next go to simulation sources. In the simulation sources, add the simulation sources, add or create simulation sources. Now my test bench, PISO shift register test bench. Copy this code and here you paste module name. Okay, shift register, select OK. File with specified name already enter other name. Okay, okay, finish. Okay, yes. Go to this test bench. So add this code, copy this code and go to here and paste, save. Yeah. So this is instance. This design is added in the test bench. Okay. So if you want to see the design, right click the test top module. Here also, if you want to see the simulation, just right click the test top module. So for seeing the elaborated design, go to RTL analysis, elaborate the design. Yeah, like this, I'm getting parallel in serial out shift register. Okay, the parallel in serial out shift register, and next close this. Actually, here parallel in is 4 bits of data. No, parallel in we need to declare with 4 bits of data. Okay, so here mistake is there. Here I need to create input 3 down to 0 parallel underscore in comma. Save this. So parallel data is coming to shift register. Parallel, first loading of data will happens, and after that shifting will be happens. Okay, so save this. Just will see what will happen. So we already given the test bed, no? So what data we need to load? 1010 here. Okay, that data we need to load. So we are giving the uh, stimulus 1010. Okay, just we'll see. Run simulation, run behavior simulation. So if you see in the TCL console, yeah, here we are getting don't care only, but here you are getting serial data. Okay, serial data is coming at serial out. Okay, so just here you can see the waveform. So here serial out data is happening. One, next 0, 1, and 0. 1010. Okay, so actually this parallel is loading is happening. Okay, loading is happening. So that we need to indicate the D out also. Okay, that's why D out if you indicate, then we can get that data into the paralleling data to the D out. Okay, D in. Okay, D in also we need to indicate. Here we are not indicating. That's why we are getting don't care condition. So like this, we can see the serial out data. And coming to quarters prime, so this I will close. Go to file and new project wizard and close this. Next. Okay, the path is same only. So I need to add the project name. Okay, so here I created three files: RTL, SIM, and TB. So RTL, this is my RTL file. So if you copy this module name, okay, copy this and here you paste. Next and next, add the RTL file. RTL, this is my RTL file. Upload the RTL file. Okay, so uploaded the RTL file and next select any FPGA family. Next, next, and finish. Yeah, my RTL file is added. Go to analysis and synthesis. Start. Yeah, I got zero errors. Go to expand this analysis and synthesis, and in this analysis and synthesis, uh, next netlist viewer is there. No, netlist viewer, RTL viewer. Right click, open. Yeah, like this, you are getting the netlist. Four D flip flops are there. Parallel in data, 4 bits of data. Serial out, clock, and reset. Okay. So this is we can see in the quarters prime. And coming to the model sim, okay, we'll see how to execute in model sim. Just go to model sim. In the transcript window, just give the quit sim, sim, quit hyphen sim. So file, give the project name, new project. Yes. So what is my project name? Give the module name only. Okay, PISO shift register. Okay, so PISO underscore shift underscore register. Okay, default work library is work function only. I'm in the same path. Upload the RTL file as well as TB file. So RTL file, PISO, select this PISO, open, OK, and add the existing file, browse, go to Testbench, add PISO, open, OK, close. Okay. Now what you need to do, you need to select this too, or you can write compile all. Yeah, compiled. Go to library, next TB shift register, right click, simulate. So you can see in the transcript window also. Okay. So here if you see the, so that means here what you need to do here, this waveform is there, no? Just here you can see right click, add wave, TB file, right click, add wave. You need to group this Testbench and DUT files. So just expand this and I can see what are the Testbench files and what are the DUT files. So here these are the Testbench file. Right click, group, give as TB, OK, and select this. Right click, group, DUT, OK. Next go to run. OK, no. Now you'll get the waveform. So here this is the code, Testbench code. Go to waves, expand this. You got in transcript window also. Serial out data is coming here 1010. Okay. And you can see in the waveforms, just a zoom fill. So here you are getting the serial out data at D out. So here during this passage of clock, 1 you are getting. And next to 0 you are getting. 1 and 0. Okay. Like this we can see the PISO. Okay. So this is how we can write the code for PIPO and PISO in Vivado. Okay, EDA playground, Vivado, QuestaSim, and Model Sim. Okay. So with this we completed the day 12 by using by day 12 we completed the shift register concept. Okay. Next in the day 13 we'll discuss about the counters. Okay. Thank you.